Hello, my name is Parshari and today I am going to demonstrate electronics lab 2. So in this lab I am going to demonstrate Wheatstone Bridge and low pass filter. So this is my ID. Let us begin. Okay, so in part 1 of this Wheatstone Bridge measurement, firstly we have to find out that these resistance value using this multimeter. So let us do that. It is around 95.7. $95.1. Okay, 96, and this last one. Okay, 94. Here resistors. This is our node A, this is our node B, and at C 2.5 excitation voltage will be connected through our ADLM 1000 kit, and at D the ground is connected. So I have calculated that VA is equals to 1.25 theoretically. So our idea is to check this VA at this experiment, that what will be the value, is it similar or is it different. Okay, so let us check the voltage at node A. Just a second. Okay, so it is around 1.25, and what about this node B? Okay, so it is also around 1.25. So our experiment is correct in terms of finding the voltage at node A and node B. So let us find the voltage between A and B, node A and B. Okay, so it is 0. This white wire works as output through this channel V. We have found the output voltage, and this ground connected to there. So our idea is to check by addition of +1 sin omega t to this graph. So there we have found that this their input is varies 1.5 volt to 3.5 volt, and output voltage is around 0.7 to 1.8, prox 1.19. As we connected to node A, let us check this node A from node B, and yeah, it is almost same as node A. So this works fine. As for this is a Wheatstone bridge, node A and node B, the average output voltage should be equal. Okay, so all the points, all the voltage comes between these nodes comes nearly equal. So it acts like a balanced Wheatstone bridge. Okay, so in part 2, we have to ask that in this Wheatstone bridge 100k, 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 and 100k, we have to add a 1 kilo resistor uh, in series with R1 and another 1k resistor in series with R4. So let us find out the voltage between that node VA and VB and verify that this Wheatstone bridge is still balanced or not. So firstly we have to check the voltage between just a second. Okay, so it is 1.25. Let us find the voltage at node V. 1.21. So clearly it is not a balanced Wheatstone bridge. There is a difference. Uh, Let us check the voltage difference between VA and VB. Okay, so it comes out at 0.016. In part 2, that we figure out that a slight change in the Wheatstone bridge, like if we add the 1 kilo ohm resistor in series with R1 and R4, creates an imbalance to this balanced Wheatstone bridge. This 100 and 1 kilo ohm resistor, we have equivalent to this a single resistor, uh, which we called as R Thevenin. Uh, that all these resistors changes to this single resistor, and in addition to there is a capacitor in series with this resistor, and through ADLM 1000 we have powered channel A to this input of resistance and a node, and channel B to the node of resistance, and in addition to capacitance there is a ground. Now what we have to do to measure and record the output voltage using this multimeter, and through our laptop screen or on Pixel Pulse app, that how the measurement of this we peak to peak voltage frequency varies. So here I'm going to change this 3.5 and vary this frequency to 10 to 1 kilohertz. First 10 to 20 to 30, and we see that there is a slight change. So we are going to note this data and make a table of frequency and output voltage, and we calculate cutoff frequency which is around 160 hertz. From thereafter, the change of frequency, or we can say the output voltage, there's a slight change in the diagram. So I'm going to measure this frequency up to 1 kilohertz and measure the output voltage, and then after I conclude the graph for this given measurement. So this is the graph of the measurement of voltage and the cutoff frequency. So in this graph, we can clearly see that if we increase the frequency, the cutoff, the voltage is decreasing because it is the low pass filter.